So here we're given this rhombus and we're told that its perimeter is 40 meters. So in a rhombus, all sides are equal length. So these would be 10, 10, and 10. And what I'll do next is to drop this altitude. That's the altitude of this rhombus. And we're given that the area is 96. So that would be the base times the altitude. Let's call it h. H is 9.6. Now I know this length, and I can figure this out. Why am I doing all this? Because that will help me eventually figure out one of the diagonals. So I can figure out, if I call this point CE, CE square plus 9.6 square is 10 square. So that would be, I think it's probably best to just use the calculator here. 9.6 square, I get 7.84, and then I take the square root, and I get 2.8. So that length is 2.8. Now if we look at the larger right triangle, we know that length, which is 12.8 meter. We know the height, we can figure out the longer diagonal. So that would be 12.8 square plus 9.6 square. And if you do this calculation, you get a nice number, which is 256, which means D1 is 16. Now another important property is that the area of a rhombus, which is 96 here, is the product of the diagonals, the two diagonals divided by 2. I know one of them is 16. Therefore, the other diagonal is 96 over 8, which is 12. So now I have the total lengths of these two diagonals, 16 and 12, 28 meters, and it costs 125. So I can just multiply that by the cost per meter, and I get 3,500. And that's the answer. Now, so just make sure you understand where this result comes from, why the area is the product of the diagonals over 2. Also, it is the base times height, and then also the important idea of kind of creating this additional right triangles to relate these different dimensions. Those are the key ideas for this question. So in summary, the answer is 3,500.